Hello and welcome to another Editor++ tutorial. Today we will be creating complex moving items from vanilla blocks. So you'll notice these two pushes here. So they're both custom items, and what you'll notice as well is that obviously this one has the wrong parts moving. So let's talk first about the structure of these items so we can figure out what we're going to have to do, and then we'll proceed to prepare an item and then do the necessary things to copy over one item into another, sort of completely restructuring it as we go. So one of the things immediately is that if we look at a standard pusher here, so the structure is that it's a prefab. We've got three entities. Now the last entity here is the kinematic constraint. So this is what determines the actual movement. Now you'll notice that the functions here don't seem to really make that much sense. Like the translation minimum and maximum is 0. However, we can see that this is actually moving. What we're seeing here is this is the default kinematic constraint for sort of the base object, which is this one. Now, sort of as a curious note, you'll notice that this is simply a static object. However, it has the same structure, and it still has a kinematic constraint here, and this is actually the kinematic constraint we were looking at. You'll notice if you're running in SIG developer mode, then you'll see these pointers, and in this case we can see it ends in like 23E0. And if we go back and look at our other pusher, you'll notice that it ends in the same thing. So what that means is that this is actually the same in-memory object. Cool. So this, by the way, you'll notice the FID here for this model is, so it's obstacle pusher 4M prefab with the base model here, and when we go to the other one, the moving one, then we've got this little question mark. I think this basically means that it's a sort of a temporary virtual file that it's created that combines other things together. That's to do with like the way that these objects are painted, like these ones, is that they're sort of skinned, and so there's a bunch of materials that get replaced from the base model on the other one. Anyway, when we're creating the custom item, Editor++ will take care of a lot of those details for us. So, getting back to the structure of this object, we can see that we've got three primary entities under the prefab. The last one is the kinematic constraints. We can sort of ignore that one for our purposes at the moment, and you'll see why in a bit. What we're doing at the moment is looking at the structure, and particularly we're going to count how many sort of spaces we need within the object we're creating. So under the first entity here, so we can see that it's the Dyna object model. So this is the moving part. So we'll want to copy this, but ultimately we won't be loading this into a dynamic object necessarily. We'll load it into a static object. In this case, for the sake of simplicity, we can make it a dynamic object and just set the movement to 0, similar to the base pusher. But we'll come to that decision later. So that's one entity that we're going to need to copy over, this moving part. Under the second entity list here, we'll see that it's, instead of being a model, it's actually a prefab. And this prefab has 3 more entities. So we've got entity 1, 2, and 3 there. So under this, there's a few sort of things that we're going to need to take into account. So the first thing we'll notice, this first one is the box. So we can sort of see what we're talking about here. So this is like just the outside sort of shell. That's one thing we're going to have to copy over. The second entity in the nested list here is the back of the box. So that's another thing we'll have to copy over. This back bit here. Now you'll notice that so far these the rotation and translation things here, quite means quaternion. They have mostly been the same, but now we have some actual values. So these first two values are pretty close to 0, but then the second value is about a -2. And when we copy over the meshes, we're going to need to replicate these values to make sure that they copy over correctly, essentially. So for that purposes, it might be good to have a notepad open when you're doing this, just on a second monitor or whatever, so that you can copy down any of these values that you need in order to recreate the item. You'll see why we need to copy these down and transcribe them in a moment. One thing as well, so we're going to try and maintain some of the same structure, but we are going to change the structure. By structure, I mean the tree structure here. So we've got, in our normal vanilla item, we've got sort of 3 entities nested under a prefab, and then the middle entity has a prefab which then has 3 more entities. So what we're going to do is we're going to just linearize that essentially. So we're just going to have a big list of items, and we're not going to worry too much about that internal structure. The reason it has that internal structure is that, I mean, you can see this prefab here, that obstacle pusher box prefab, that's common among all of these pushers of this size. And so it just refers to, like, basically everything's been packaged under that, and then it can be reused. So the structure of these items sort of represents the structure of how they've been created by Nadeo. Okay, so our middle one here, we had the pusher back. There's only one entity under this, even though it's a prefab, so that's just another one. So we've got 3 entities we need to copy so far. And then if we look at the last one here, we've got another prefab just with one entity, and this is the front of the box. So that is this like metal grill around the front. It's that bit. Yeah. So that's our box. It looks like the metal grill needs to be set 2 units as well. So you can see that we've sort of got the center of the object, and then there's something 2 units in front of it, the grill, and something 2 units behind it, the back, and otherwise things are centered around the origin. So that's pretty straightforward. The rotations are all, I think they're all just 1. So yeah, we don't care about that one, and under here, yep. So the only thing things we need to copy down are the back has a z equals minus 1.92714, and then the grill is z equals 2. Cool. Okay. We will need to note the structure of this for when we're copying it. So I'm just going to make some notes here. We've got the dyna object, then we've got a prefab, and then under that we have the box back, and then the grill or front thing, and the kinematic as the last one. Okay, so that's our structure. Now we only need, what we're going to do is we're going to create an object with a different structure that'll be easy to copy things into and easy for us to maintain. For that, we're going to create a custom version of a different item, and then just get rid of all the models and meshes and things within that item, and then we're just going to populate it from there. So so we're going to look for something with at least 4 entities, like a prefab that's as close to 4 entities as we can find. More is okay, we're just going to nullify everything after 4. But less is a bit of a pain. You can work around it, but it's just a bit of a pain. Once we do that, we're going to copy in, one thing just to point out, because we've actually got 3 separate moving items in this odd pusher here, this confused pusher. And that is the grill at the front, the box, and the thing at the back all have to move the same, but the actual sort of pusher bit doesn't have to move at all. So what we're going to do is we're going to find an object with 4 slots and make a custom version of that, and then under each slot we're going to put both a dynamic object and the kinematic constraints. So if we look at the structure of this one that I created earlier, this is a bit of a mess, but it will demonstrate the point. So it only has 3 entities, and that's because the last one then has 2 entities, so that's how I get the sort of 4. And then under each of these, this prefab, they both have 2. So you can imagine this as just one list of 4 entities. Under each entity, we're going to have a prefab with 2 entries. The first one is going to be our dynamic object, and the second one is going to be the kinematic constraints. And so we'll have a list of 4 groups of 2 entities in this pattern. That's our goal for the object, and then once we've prepared an object like this, we can then copy the meshes and things in as we need them. So we understand what our source object looks like in terms of requirements. Let's find a suitable replacement. So if we just like pick any random object here, like this pole, this is not suitable. So it's not suitable because it's a variant list to start with. Under each variant we can find prefabs, so we could use those prefabs as our initial source, but we'll just try and find one object that meets our requirements just because it's a bit simpler. This also then only has 2 entities under the prefab, so that wouldn't work anyway. These barriers, so we can see there's a variant list again, but we do have a prefab with 7, so 7 is maybe doable, but it's a bit too many. If we go to inflatables, and this is really where things are pretty good, so inflatables have a large number, like a decent sort of variety that you can use. So this first group here seems to have 7 entities under the prefab, which is pretty good to start with. The curves here, so this one has 6, which is nice. This one has 7. Sometimes they have different amounts, so like even though you would think these curves would all be pretty similar, this middle one has 9 entities and these two on the side have 7. So it's worth just looking through these, as this is the number of entities we're looking at, by the way, just to find something that is suitable. Okay, so here's one that's 5. That's pretty good. Whoops, getting a bit lost. So we'll just put that down there. So this will be our base item. We'll copy the name of the item here by clicking on it up there, and just paste that into our document. Okay, so this is what we're going to copy into a new item. We don't need to worry much about these, like, all these placement things will affect the item at the end of the day. So maybe it'll the same way that you can sort of snap this to things, those placement params, although they're not really parameters, the sort of placement option things. At least I'm fairly sure that's what they do. So maybe if we can find one that doesn't have those things. So this has 6. Alright, well, it's not going to really matter. We'll use this curve. So this is actually our item now. Because these ones I've used before and I know that they don't have any extra stuff. Alright, let's create our base item. So we can call this complex moving template. Okay, just get our entity model back. Under materials, can turn them to mat IDs, nullify the entity model, save. Okay, now we've got our item prepared for copying. So let's grab our inflatable mat 4M. Do this, select that as our source. We want to replace the entire entity model with that one from the inflatable mat curve thing. Click run, click save, overwrite. Okay, now let's just refresh it. Save this as 1. Okay, and what we want to do now is we don't actually care about the source item anymore, so we can just select the same one. But what we're going to do is nullify a bunch of these models particularly. So the model element here is something that we are going to be able to copy other like prefabs to. So yeah, we'll do this so we create a template and then we'll populate it with the other ones. We'll just go nod, or this one indirect, nullify, on replacement, replace more. So now we can see we've just got null under there. We're going to keep doing this for the others. Okay, cool. So we can see that we have eviscerated our item now. If we go to the model thing, we can see that the entities are all, they're there, but they're null. So this is good, because it means we have our template item. Let's exit. See if we can just edit this again, and we should, yep, okay. Now, the game is going to crash at some point. We're going to end up crashing it twice. Once now, and then once a little later on when we do some other vanilla item stuff. But for the moment, or actually before we do that, we can create a custom version of the pusher, which we need to do in order to copy everything correctly. Okay. Oh, there we go. It did actually update with our template there. Okay. So let's find our pusher. Do the orange one. Current item, obstacle pusher. Cool. So we'll just save the item and then go here. We'll select our source item as the obstacle. Replace the entire entity model with the other entity model. I don't think we need to click set item properties. We'll just save it. Cool. There we go. Oh, that's the other one. That's our custom pusher. Maybe we did. We can fix that though. Oh no, there we go. Alright, so it loaded. You'll notice that the lights don't work the same way as a normal one. That's a texture thing. It just seems to be a limitation of custom items. But we've got our custom pusher, which is good. Let's go. So we know how to find it. Okay, so let's just save the map. And I'll pause while I restart Trackmania because it's going to crash otherwise. Okay, let's begin populating our template item here. So what we'll first do is, so I've only so I just rebooted the game, loaded up the level, haven't done anything else. We'll go in here to edit our moving template item, and we'll call it odd or confused short pusher. Okay, now if we look at our model browser, we've got all of these null entities. What we're going to do first off is copy a suitable animated template item. So what we'll use for that is I use these guys, but any simple animated item will do. You can see in the model browser here we've just got two entities. There's the prefab constraints and the main dynamic model. So pretty straightforward and easy to thing. It does have all of these layouts though, which maybe it's good to nullify, but that is what it is. Okay, so when we do this, we're going to need to copy and duplicate the memory, but we don't want all of the memory locations to point to the same place. Like if you copy, so one thing you'll notice is, so this is not a good example shape. What is, yeah, so if we look at this custom rotator that we made in a previous tutorial, actually no, these go to different places. So often if you copy things, you can get them to point to the same location, and then you won't duplicate the memory when it saves, but the consequence of that is editing one will edit both. Anyway, so that was just the concern there. So confused short pusher, let's go back here, and what we're going to do is manipulate meshes, grab our template item, we'll replace the I have just realized I've not implemented something that I've meant to implement. It's because we nullified things. So ideally this null here, you should be able to set this to point to something, but that's sort of a bit dangerous because you could point it to like anything, and so I haven't spent as much time working on that feature. What we're going to do is instead of that, we will go back to our earlier custom template, this one, that one, the complex moving item template, and this will be what we'll use to do the thing, and you'll see why in just a tick. So, confuse push 1M, call it something different. Okay. Now we want to manipulate meshes. Our source will be the custom pusher thing that we created, and no, our source is going to be the balloons first. Okay, now we want to replace the model. So this was the problem with the nullification, is we now can't replace it, even though we sort of theoretically can. If you edit the memory, you could, for example. Okay, so we want to replace the first entity in the list with the entire prefab from the balloons. So I'll just go run, and then we'll save this, leave the thing, edit it. You can see we've now got our, it's updated. So again, manipulate meshes, select the rot balloons. The reason we're doing this is we can get rid of the first entity, is to avoid creating identical memory regions. So takes a little bit, but this is the easiest way to do it. Yeah, if we look in the model browser now, we can see that it's updated with the new one. What we want to make sure is that, so this address C8E2 is not the same as this address 04F0. Save it. Edit it. Select the prefab, run, save, leave, edit. The prefab, everything, run, save. We can actually, at this point, because we don't need the others, we can go back here and nullify these. Yep, now if we go back and we edit this, we will have 4 objects. Now, you can't see, there's some that are overlapping, and they're not all moving. So why is this? This gets to the next part of what we're going to do, which is to configure the kinematic constraints so that this works. Let's do that first. Under each prefab here, where we've got a dynamic object and the kinematic constraint, what we need to do is change this number, the dynamic object index. So this index is, so it's a depth first searched ordered list of all of the dynamic objects that are within this item. So basically that means that the order that they appear in this list is the same order that this refers to. So the first one here is 0, that's fine, but the second one we will need to, you can turn off shadow as well. The second one we will need to edit to change this to 1, And then the third one we need to edit to change it to 2. And then the fourth one we need to edit to change it to 3. And then those we don't care about. Okay, let's save this again. We'll go back, and now you'll see that they are all moving. Cool. Alright, now we need to replace the actual meshes themselves. So our source object was the editor++ tutorial custom pusher, and get rid of those. And then here we want to replace the children of the dynamic object model, and we'll do this in the order specified from, or in the order of the other source object, because that's how we recorded them before. Alright, so that's the first one, and then second one we change that to all children of the second one. Got the box. Third one, all children of this first child. All children. We did an extra one, so this is actually the last one. And then I'm going to go back here. All children with the middle one. Okay, so now we should have, yeah, so do we have the back? Yes, we've got both the back, or I think that's the back. Anyway, let's keep going, and actually we can check here. Just going to save and reload the item. Okay. So it seems like I've made a mistake somewhere. What we'll do is continue through the process, and that will end up showing us which part is the error, or where is the error. Anyway, so the first thing that we want to do is to replicate the kinematic movement of the actual pusher, but with our sort of the inverse of that. So if we have a look at the pusher here in the model browser, then the kinematic constraint was way down the end. We can see that it's so the translation is from 0 to 4 in Z. There's no rotation, and the animation functions here are, we've got quad out and then false 2000. So quad out, false 2000, and then just the same but true. Okay, so that's all the details we need. This one doesn't matter. And what we're going to do is apply the opposite of that to each of the parts of our custom item here. So in the model browser, when we edit it, down here with the rotations, we can set all this to 0. Yep, okay, so we do have all 4 parts. You can see the grill at the front there, and then the back part there. So we didn't actually make an error. It was just that it was hard to tell. So something to keep in mind. Cool. All right. So no rotations or anything now. One thing that we will notice though is we might have some. So the locations of our entities here were not zeroed, whereas they were on the previous item. So we need to set all of these to 0, at least at the moment. That'll reset all their positions, and then we can copy. Well, actually, we can set everything now. So our notes from before, it was all of the rotations were 1, 0, 0, 0, which is fine, and then we had the back part, which was our second to last entry, had Z of minus 1.92714, and the front part had a Z of 2. So if you type in more decimal places, it'll still set correctly, even if it doesn't show them. Okay, so we can zero these, so we may as well at the same time. That looks pretty good. Let's just go save. Okay, and then we'll edit the item to refresh it. Cool. Now you can see we have an item that looks like it's all in the right places, because we've copied over the rotations and positions and stuff from our template item, or from the source item. Okay, the last part then is to go through and change the animation functions. The translation ones. Unfortunately, we can't copy paste these yet, so it's a bit manual. But it is what it is. So that's what we're going to copy them all to. You can see that there's also like other entity offsets and stuff buried deeper. So in the case of like our template item, this like in the balloons that we copied from, that's not too much of a problem, but it's just something else to be aware of. I don't know how these stack and how they affect things, but I'm sure you can experiment with that if you're curious. So we wanted these. Oh, we need to set the so the translation minimum, instead of going from 0 to 4 to 4, we're going to go from -4 to 0. And that will that gives us the inverse movement. So why is that? Oh, yes, of course. Because the actual box pusher part we don't want to move. So that's why it looked odd. The reason the animation lags is just to do with the way that it reads these functions, and when you refresh the item it all works out, but it will glitch out like that when you reduce the period of the animation. -4, translation functions, doop, doop, doop. Alright, so -4, -4. Okay. Let's save this. Then we will edit it again. Okay, now you notice there's some little shadow bugs, or what look like there. That's because like the back is casting a shadow in an odd way. To fix that, we're just going to look at the not the prefab constraints. On the dynamic object model, there is this S instance params, and we just want to turn off cast static shadow. We can actually do it for the first one, because that makes sense to have a shadow, but for the other ones, we want to turn it off. Okay. Let's take a thumbnail as well. Okay, so now we've just got a shadow for the main pusher part, which is what you'd expect, and the other bits are don't cast a shadow, and that is our object, our confused pusher. So that's how you'd create a complex object. So just to sort of recap, we created an object with a new structure. We created a custom version of the vanilla object that we could use a bit more safely without crashing the game. We copied the kinematic sort of prefab over multiple times, as many times as we needed it, in order to create new copies of in memory. And then within each of those, we then copied the various components of the source item, or the custom item that we created as our source item. We set the location and translation properties so that it would mimic the original item. We set the what do you call it? The various, the dyno object indexes and the kinematic constraint properties, and yeah, and that gives us a confused pusher. That's pretty much it for that one. One thing to note about vanilla items is, so not all, you can't create custom versions of all vanilla items. So for example, trees are, they're this cplug veget tree model thing, and those won't save. Even when I try the tricks to save the other stuff, it doesn't work with these. So I'm not sure if it's possible, but those won't work. There's various other things that can cause issues, like for example, if we look at the, like one of these, whoops, that's a crash. Okay. It might be because it wasn't loaded in the level. There was something was expected to exist that didn't, so apparently that's just a thing for that model, or all of these. Okay. Well, that's a new bug to look into. So the issue that we're running into, so it's something that might be related to previous research I was doing actually. Basically, like in-game checkpoints and stuff can have these block helpers that they're called, the arrows, but custom items can't have them. So we've got to sort of like remove those or nullify them, but apparently there's a bug in the current version, so which I'll fix. Yeah, I was actually going to show you those particular parts of the item as examples of stuff that doesn't work. Is there anything interesting here? Oh, some things I've tried to make sort of work, like the FX system, so in terms of sparklers and stuff. They don't seem to work all that well, but some bits do work, I think, with creating custom sparklers. With screens, like they're not skinnable or texturable, unfortunately. Yeah, anyway, so not all vanilla items work, but many do. Yeah. Custom moving pipes are possible. You need to do a similar thing where you've got to create multiple entities. Actually, custom moving pipes are a bit harder because you'll notice that in the entities thing here, so we've got this first one has like a mesh and a shape, which is sort of what we'd expect. But the second one, which is one of the end caps, has a mesh but no shape. Now, you can't, while a static object model can have no shape, a dynamic object model needs a dynamic shape, otherwise it crashes the game. And so you've sort of got to work around that by creating a different shape to put in its place. But that means that there is some collision somewhere. So the workaround I came up with was creating like a very small cube several thousand units away, and that's the collision for the object, for the end caps. But yeah, you can see they're called plugs. So there's a few sort of interesting things to sometimes work out with some of these items, but in general a lot is possible. Anyway, I'm rambling a bit, so I'll leave it there. Cool, have fun.